Good afternoon, Professor Grubbs, Carlos. If you're watching this, good afternoon. We are the VDOT CDO project team, part of VCU Capstone project. Here we're going to tell you a little bit about what we've done this semester towards kind of implementing this solution for VDOT.
Hi, I'm Ryan, and we'll start it off. First, we got the idea from Professor Grubbs. He decided we were going to do he offered this idea that we got from you about the information sharing environment in which we're going to create a database in Google Chrome or in Google Drive in the cloud, and then we're going to be able to access open source data from multiple data sets from various, particularly VDOT in this situation, but it can be applied to various government sites and open source data sets. And we're also going to make a NIEM conformant so that it's possible to be that all these data sets can then interact with each other, and they're all in the same universal language that the government can use. And so first we wanted to think, when we first got this idea, we wanted to think about the user stories. We wanted to talk about who are the people going to be involved in the using this application that we're building. First, people that we had to focus on is the data entry. Where's this data coming from? Where's the open source data being starting? And so we decided that we had to focus on them. We had to understand where are they putting their data? How are they formatting? And then we had to be able to put that data into a database. And we also had to focus on the people that would be interacting directly with the database. So we're talking about administrators and people inside the government. And then we also had to talk about data analysts, where the people that would be using the data that you're now providing access to in a much more streamlined capacity. Those people we're going to help through using BigQuery and general database querying options for geospatial data, particularly in this situation. And so here's a better outline of this of the diagram, the solutions diagram. First, you have our open source data here, and it'll be we're then process it through NIEM, through a NIEM IEPD, in which we will then be able to format the data into a compatible format so they're all in a single language of NIEM that our database can then operate in BigQuery and in the Google Cloud Platform. And then we also have some identity management to decide who's going to be accessing this data. And so first we had to figure out what exactly NIEM is, and I've been saying it multiple times now. It is a universal language for databasing. It makes it very efficient for information exchange. So it's pretty much converting languages. So saying it's English into a very universal language, and then Spanish into a universal language, so they all can communicate effectively. And so it's all independent, and it's much easier to deal with for individual systems such as this. And here's a better example, a better diagram of this situation where people, in this situation, they're using people, how would you describe a person? Oh, it's their name, their sex, and their nationality. And then it keeps defining people in different situations, but here it's all one person. This is what the idea for this whole program is supposed to be, is converting all these different languages into one unified ideal database. And so here's the life cycle that we followed. We tried to keep it NIEM conformant, so we were how we dealt with the data and how we are now converting into an accessible for database that we've developed that we'll talk about later. Currently we are in the publishing and implementation stage, where we're trying to develop the code and making sure that that the data is actually moving from the beginning, from the open source data into the database that can be accessible for engineers and data analysts. But we will always we have to keep doing this multiple times. We have multiple iterations of this going on for the past 2 or 3 months. And here's an example of one of our NIEM IEPDs. We were able to take this from, I believe, bridges and culverts data. It's sampling, but we were able to figure out some mapping. We were trying to figure out, these are actual data sets from data types from the data set, and then we had to figure out how they would link up to NIEM conformant data types, and here you can see like equivalence, where like it was pretty much a one-to-one relationship. Like it was very easily defined, but we also had to deal with partial relationships that weren't necessarily one-to-one, but they were very close in data type structure that we needed for this. Now we're going to go on to the buckets where the data was being put.
Yeah, we have the data, so now we need to put it somewhere. So what is a bucket? That's it's a basic container to hold your data. And Google offers many kinds of buckets, as you can see on the bottom of the chart here. Depending on your data needs, there's structured, semi-structured, and unstructured data. So say unstructured data would be like an image. Semi-structured data would be something like HTML file. And structured data would be that of a database. So we're going to be working with structured data. So for that, we chose BigQuery as our bucket, and it's a scalable, fully managed enterprise data warehouse, and it uses SQL. It's good for relational data, which is what we're going to. Well, actually, our data isn't relational, but it's similar to relational data. It's very scalable, works up to petabyte scale, and it's good for data mining, exploration, and the real strength of BigQuery lies in its ability to handle really large data sets. So that's one of the reasons we chose it. So we could scale up, and then it also uses standard SQL query language, so we can still use complex SQL queries to retrieve the data.
So here we kind of have like a step-by-step process of what we did on the buckets team. First, we examined the data and the metadata, tried to get a lead on what would be a good container. We learned the difference between GCP, BigQuery, and other database systems. We decided to create a database in BigQuery using the GCP console. And finally, we created 3 bucket instances for each category.
So the next part of this was kind of managing those buckets and making sure users only got access to the things that they needed within that. So me and Azichi, as the the management team, took care of that. Everyone operated via standard Gmail account, signing into the GCP environment. We had to make sure all of the monitoring tools within it were NIST 800 CT3-3 conformant. So that just meant making sure everything was properly identity proofed, managed, and authenticated within that. And a big part of this was attempting to get multi-factor authentication installed, which we were unable to do, mainly because like some weird things happening with the Google admin console, but it's something we're going to take care of in the future. And as I said, everything happened via those GCP admin user roles, so it was very easy to assign permissions for everyone. Next slide. And these were just some of these roles that we used. So everything was stored within a BigQuery container. So it was really easy to say this person only needs user access because they're just going to like look at the data and run queries. Whereas other ones maybe needed admin or editor access to be able to edit that data and change it as they needed to.
Integration team, what we did, so data integration, its purpose to convert multiple data sets into a single data format. So like they were saying, the information's coming in from different places and we need to convert it to one single format. What we plan to do, create GeoJSON scripts purposes to extract, transform, and load the GIS data set to BigQuery, and then integrate with NIEM to provide the standardization. And then this is an example of the script we would use in GeoJSON and GeoJSON. And it goes through just the addresses, line strings like streets and highways, and then like land, countries, etc.
Alright, so now we're going to move towards showing off what we have so far. So I'm going to give you a little bit of an example of what we have through BigQuery. So this is Google Cloud Platform. We have some of the data loaded in. So right down here on the left-hand column, we have the different data sets that we've created, each one for a specific category, including bridge and culverts, traffic volume, Virginia crashes. Now for this example, we did minimize the data a little bit, so we had about 50,000 rows of data for each one. Virginia crashes, I believe, we only had 5,000 rows of data just because it was such a large amount of data. But for an example, I'll give you a query that we have just selecting all the data to show off that the data is running through BigQuery. So bear with me for a couple seconds. It's going to run through BigQuery. Now, how we stored the data is we actually found that we were able to take the data and convert it into Google Sheets, which allows for JSON script editing. So you'd be able to pull the data from VDOT's website through a script file that integration would provide into BigQuery. This takes about 30 seconds, so bear with me. Alright, so here's the results of selecting all the data from it. Now, the data that we have in this shows that the column names are NIEM conformant with the mapping that NIEM has provided us. So for instance, I think it was jurisdiction. They had a different name for that, but we renamed that and mapped it to the NIEM conformant version of that. And just here's proof that it is running through the database. And we have that for bridges, traffic in Virginia as well. Now to show you a little bit about what the Google Sheets looks like, here's our bridges and culverts file. So showing that the columns again are just being matched to NIEM conformancy. And due to the sake of time, we did have to manually do this, but I'll show you how you do it through script editing. So right up here in the tools, you can choose script editor, and a neat thing that Google Sheets provides is it allows you to create JSON files directly into the sheets. So the next plan of action that we would have is we would keep the NIEM conformant columns right up here. However, on A2, going down where the data is being pulled, we would create a JSON file that would be able to pull that data straight from VDOT's website, which is open source. And all the data would be automatically pulled and placed into BigQuery. And that's pretty much the prototype that we have going on right now. Again, we do have that for bridges, traffic, and Virginia data. Let's go back to the presentation. All right, so just to finish it up, I talked a little bit about it, but you know, some of the future, if we were to continue this project, we would love to use a utility. Illuma has a weird name, but that's the utility we'd love to use. So right now we do have the data sets already in the cloud, and we also have it mapped to NIEM. But right now we're working on the script, and that's a very big chunk of it, and we're actively working on that. And if we were to continue, we'd hope to have that done relatively soon. And we'd also love, like what they said over there about authentication, having multi-factor in the future to provide absolute protection for all the users and all the data that's stored on the database. And here's a picture of Illuma, which we mentioned earlier. Just a utility that we'd be able to use with the script that would allow for kind of like a pipeline of the data moving in and out. And again, this is actually probably one of the biggest projects we've all worked on. We've never had a team size of this scale, so communication and working together was very key for this, and we've learned a lot through that process. Thank you.